done so we can get to the review. All right, so geometry, polygons, and perimeter on the coordinate plane worksheet. We did number 1 together, so turn the page on that. That should be correct. Let's look at number 2. If you can count, we should know that this is 5, this is 5, this is 5, and this is 5. How do we find the diagonal sides? Yeah, we draw our triangles, right? We do Pythag. So if I draw a triangle here, that's 3, and then complete the bottom, that's a 3, 4, 5 right triangle, isn't it? So this length is 5. How do I know that? Because 3 squared is 9, 4 squared is 16. Add them up and root them. 16 and 9 is 25. 25 rooted is 5. Pythag, right? That's what's going on here. A squared plus B squared equals C when you root it. Okay. Same thing here. You'll notice this is a 3 and that's a 4. So this is also a 5. Mr. Eads is correct. All of these are going to be 5 because they're all 3, 4, 5 right triangles. So we have an equilateral octagon. Doesn't mean it's regular. Remember, regular has to have equal angles and equal sides, and all we know right now are the sides are equal. All I wanted to know was, 1, that it was an octagon. Convex or concave? Convex, because concave caves in. Remember, there's a couple ways to check for concavity, right? So when you're checking for cavities, what you want to do is you want to extend these lines out. See if I extend these sides. None of those sides would go into the interior, would they? They all stay on the outside when you extend them. Another way to do that, a more mathematical way of doing it, is if you look at the internal angles. Remember, internal means inside, right? Like inside voices. So these internal angles are all less than 180. All of those are less than 180. Gentlemen? All of these are less than 180, so therefore this must be convex. If we have those hyperextending elbows inside, then that means it's going to be concave.
This dude put a 7 and got one as an 8.
Oh, man. Counting is hard. Tucker, do it when I'm not looking. All right. So, Tucker, I'm asking you just for fun. How many 5s are here? There are 8 5s. So what's the perimeter? 40, right? 40. He's got 40 chickens. It's a lot of chickens. Look at all those chickens. Number 3. We can count, I think. This is 5. That's 5. Now here's the problem. The rest are diagonals, right? How do we find the diagonal sides? You make a triangle. I love my 5th hour. 3 is here, 4 is there. So if it's 3, 4, what's the length? 5. Check it out. That guy's a 5 as well. That guy's a 5 as well. That guy's a 5 as well. Guys, it's equilateral. Amazing. Why is it 30 for the perimeter? Because it has how many sides? She's double checking. She doesn't want to pull a Tucker.
It's a hexagon.
Hexagon, 6 sides. She was right originally. Concave or convex? Concave, because here's the break in your elbow angle, right? The reflex angle, more than 180. That's concave. Another way to think of it is, again, to extend those lines. If I extended this out, see how it would cut through the middle? The internal, or the interior, I should say. 2 points, 1 for each of those, right? Next. Number 4, what kind of polygon is that? Quadrilateral, very good. It is also a parallelogram, but that's a specific kind of quadrilateral. Quad means 4. Ri is a connection word. Lateral means side. So 4-sided, right? Concave or convex, Mr. Eads? Convex, because if you look, all of the angles inside here, that's less than even 90, right? That's still less than 180. That's still less than 180. That's still less than 180. All of those are going to be less than 180, which means we have no reflex angle, which means it is not concave, which means it is convex. If you can count, and I can, this is 13, and that's 13. How are we going to find the diagonals? Well, we're going to draw a triangle, right? It's a 5 by what? 5 by 12. Ladies and gentlemen, you probably know what 12 squared is. What's 12 squared? A lot of people have this one memorized. 144. And that's usually as high as you go, right? Like after that, you're just like, whatever, I'll get a calculator. What's 5 squared? 25. Only thing funnier than 24. Now check it out. When these two numbers combine, what do they make? 169. Nice. I make my own quizzes, tests, and homework. All right. Root 169 is actually a perfect root.
13.
It's 13. So when you were younger, you were mature, and you stopped at 144 because you're like, why would I go further, right? But now you have a reason why to go further. 13 is 169. Okay? You'll never forget that one. You know why? Because psychological scarring is a valid form of education.
I already forgot it.
13. It's equilateral again. Yay, woo! Fantastic. That means we can just multiply by the number of sides, right? What's 13 times 4? 52. Do it in your head. 13 times 4, right? 13 times 4 is just 10 times 4 plus 3 times 4. 40 plus 12, 52.
He didn't do the triangle and he got his answer wrong.
You plugged in the numbers for distance formula? Okay, I was going to say, rest in peace for all those points. Okay. Counting, that looks like a 3 to me, that looks like a 2. All the other sides are at an angle, so we have to do Pythag, right? So check it out. I can do Pythag on the inside or the outside. I'm going to do it on the outside. There's 3 there, and there's 4 here. So this is our favorite right triangle, a 3, 4 what? 3, 4, 5. So that's a 5.
A and B is a 5.
EF is next. Let's do that. Looks like a 4 by 3 right triangle, right? So if it's 4 and 3, it's going to be 5, right? So we have a 5 here. Why am I doing tick marks here? I shouldn't do tick marks there. 3 is not congruent to 4. All right. This guy, oh, we do know this one. This one's 5. Right? We can count that. This next one, you'll notice, is not a 3, 4, 5. It's very close. There's the 3, right? And there's the other 3.
Square root of 18.
That's right, because we have 3 squared plus 3 squared is 18, right? 9 plus 9 is 18, and then we root it. And we get root 18. So that's not congruent to the other side, so it doesn't get a tick mark. This one over here, 4 by 3 again. So that means this is a 5. This one up here, 3 by 4. So another 5. It's a lot of 5s.
You know, you could use a ruler for this.
I could, but I don't want to. 5, starting here, plus 3, plus 5, plus 2, plus 5. Using colors helps because all I have to count are the red numbers. Plus 5, plus root 18, plus the last 5. That's a lot of 5s. Mr. Eads, I don't want the answer. What I want is this. How many 5s do you see here, Mr. Eads?
6.
He's correct. There are 6 5s here.
There's 5.
No, there's 5 5s, but there's a 6th one right here because 3 and 2 makes 5. So 6 5s, we have 30. And then we have an 18, root 18 left over, right? So 30 plus root 18 is your answer. Alex.
Why did they say square root 18 so it's 9?
So check it out. Great question. See how that's 3? See how that's 3?
Yeah.
So we have 3 squared plus 3 squared. What's 3 squared? 9. Plus 3 squared again, 9. That's 18. Root it. It's okay. Just didn't see it.
What if you have it in decimal?
Nope. Gross. Disgusting. Won't have a calculator tomorrow. Here's what's going to happen, okay? When you get an answer like this, like if I had x plus 5, would you try to combine those? No, that you just, it's done, right? We're done. Same thing here. Roots and regular numbers don't go together. They just stay separate.
Oh, I see.
Now, could you get a decimal? Yeah, sure, but like why? It's extra work.
I did it, but I guess you have to add 30 to that decimal.
Nah, just leave it like that, man. Easier. Real mathematicians don't go and get a decimal for this. Because like no one cares. It's more work. Why do it? Just circle it, right? Or box it. Although, okay, what if we got something like this? Like we did a thing and we got something that looked like this. 5 plus root 18 plus root 18 plus root 7. Okay? Could we simplify this? Yes, we can, and here's how. You don't need a calculator, okay? How many root 18s do I have here? So that's the same thing as 2 root 18s, right? Not squared, we're not multiplying them, we're adding them, right? So 2 root 18s. 2 times root 18, right? Root 18 double. Now the 7, can't do anything with that, right? We only have 1 root 7. Okay? A lot of times I see this. Watch. These are common mistakes. Okay, we have two common roots. They have the same number on the inside, right? So root 18 and root 18. I see people tell me that that's the same thing as root 36. Why did they say root 36? What was their thought process, you think? Oh, I'm sorry. They added the inside numbers, right? Now, how do we know this isn't right? Well, because they told us it isn't. No. Think for yourself. If we had to estimate what root 18 was, how would we go about that? No idea? You know what root 25 is, don't you? That's 5. Do you know what root 16 is? 4. Root 18 is between those, right? I mean, 16, 18, 25, right? So root 18, whatever it is, has to be between 4 and 5. Okay. So some decimal, right? 4 point something. Does 4 point something plus 4 point something equal root 36? What is root 36? So we have 4 point something plus 4 point something equaling 6. Is that possible? No, it's going to be at least 8, right? If we got two of these guys, the smallest it could be is 4. It's not. That guy's 4, but let's pretend, right? As small as it could be is 4. If we double it, it's 8 as small as it can go. So it can't be this. That's impossible. You can't add them up like that. It'd be convenient, but you can't. Another common mistake I see. Mr. Eads mentioned this. Square them. Squaring is multiplication, right? It's like putting a number on a square and finding its area. Area is multiplication, right? Are we multiplying or adding here? We're adding. Different. And how, I know it doesn't work, because it'd be nice if it would. Squares and roots cancel. So you're telling me that root 18 plus root 18 equals 18. Now, what did we say root 18 was approximately earlier? 4 point something, right? So you're telling me 4 point something plus 4 point something gets you 18? Can't be that. Sorry, Chief. That ain't it. Questions, comments, concerns? Other than from my mental stability? No? So you can combine them if they're the same number on the inside. And the way you combine them is not by adding them up, but by saying I have two of them, right? Root 18 plus root 18. Another way to write that is to say I have two root 18s. That's all. It's like I have an x and I have an x. I have two x's. Last page. Draw an example of a convex regular pentagon. It doesn't have to be to scale. Ah, we love this. It doesn't have to be to scale. You know how easy it can be to draw something if it doesn't have to be to scale? Pentagon has what?
Can't see it.
Oh, 5 sides. I thought you were booing me. 5 sides. 1 side, 2 sides, 3 sides, 4 sides, 5 sides. There's my regular looking convex pentagon.
No.
Regular means all the sides are the same, right? Do you see how it's not the same, but I can just say it is? And if I say it is, it has to be. It's so easy to draw this. You don't have to be specific. You don't have to bust out the protractor. You don't have to bust out a ruler, okay? Now, regular doesn't mean just equilateral. It also means equiangular, right? The angles all have to be the same. So the last thing you got to tell me is that all these angles are the same. Are they actually? Dear God, no, right? But like I said they are, so they are.
One's not choose.
Close. It's a little less than 180. If it was more than 180, then it would be concave. Mr. Eads. There's a straight line. Straight line, straight angle. That's 180. That's a little bit less than 180.
179.
Which is less than, for the people watching at home. Which is less than,
So just drop out.
Tucker, would you like to fill in the blank for him? 179 is less than, what? 180. Good job, Tucker. Tucker knows how to count. All right. Can you ever have a concave triangle?
No.
No. Here's why, okay? Here's why. Triangles, when you add up all their angles, no matter how you draw them, all of those angles are going to add up to 180. So all 3 angles add up to 180. So how can something that needs to have 180 on the inside, remember to be concave you have to have a 180 on the inside, how can an angle on the inside be 180 when all 3 of them have to add up to 180? You see what I'm saying? We shot our wad early. If that one's 180 to make it concave, then there's none left over for the rest of them. So we have those guys being 0. You know what happens when you have those guys being 0? You get a flat line. They collapse onto each other. There's your 180 degrees, right? So there's no way to make a concave triangle. There's just not enough points to work with. Now what if I had 4 points to work with? Could I do it with 4 points?
Yes.
Where would I put my point to make this concave?
Nowhere. In the middle.
How do we know that's concave? It goes through, right? Another way to look at it is reflex angle on the inside, right? There's our greater than 180 degree angle right there. You can't do it with 4, but you can't do it with 3. Anything else easy, right? 5. Yep, 4 points minimum, right? Can't do it with 3. Has to have one of the angles be bigger than 180. In triangles, all the angles add up to 180, so it's just not possible, right? Self-development, do it or don't. I don't care. If you did it, great. I'll give you 2 points. If you didn't, you can work on it till the end of the semester if you want. Screenshot it, whatever. Turn it in if you like your grade. Every one of these is worth 2 points except the last 2 for a total of 12 points. Anybody need a pen to put the grade on there?
I just draw a big 0.
You need it?
Yeah.
There you go, Doc. Eads, don't throw stuff in my classroom.
I was, and I was falling.
Oh, you were tossing? Oh, that's fine. That's fine. I encourage tossing. I think it's the more efficient method. And it's only dangerous if you can't catch. Which, honestly, that's your own fault. Right?
Yeah, please don't.
I won't. Buckets. Buckets. All right, nerds. It's review packet time.
Come over at 7.
Whoa.
6.
Gentlemen, not
Yeah,
while I'm
prevent
watching.
you from hitting Mr. Mental. I'm a nice guy.
Not while I'm watching. Because in theory, if I'm watching, I have to do something about it.
Did he snap in the
And
head?
I'm not about
Yeah.
giving things.
Can you turn around a second?
Not right now, because I'm busy doing something.
Okay.
But I will turn around and Mr. Eads, I think you need to watch out.
I think I'm good. I've looked them before.
Yeah. Okay.
Was I sleeping or something?
Whoa. Right, here we go. So,
Okay.
hey-o.
It's only a game if you make a game.
Sorry, I stepped
10 points. You didn't think I'd make that, would you?
All right. I'm facing forward now. The review packet. It has an R on it because if you'll notice at the top it says geometry test number 1. And good Lord, am I not giving you a take-home test?
Why not?
Why even do it at all?
I'll pass.
Right? Why even do it at all? Like, if we're going to do the take-home test, why don't I just give you the A and save everybody time, right? Because literally the only reason you wouldn't get it done is if you didn't have the life skills to do it. So now I'm grading your life skills. Which is not the point. I don't want to do that. You suck at life, right? We all know this, okay? Not fail everybody. All right, so here we are. A regular review packet. That's what the R stands for. I just called it test 1 because how I make this and how I think most of your teachers make stuff is they take all the homework and quizzes from before, they throw them all into one Word file, right? They cut out the ones that overlap, they change the numbers, and they make the review packet based on that. And then to make the test, they take that review packet, they cut out the ones they don't like, change all the numbers, and then you get the test, right? So I did that last night, and I forgot to change the name of this thing. It should be review packet. Geometry test number 1 review. So I bet you're going to want to see number 2. I bet you're going to want to see number 3. I bet you're going to want to see, not number 4, because that one's midpoint, right? It's 1-to-1. That's not that bad. What you'd probably rather see is this one, number 5. You definitely want to see number 6. You don't care about 7 or 8. You might want to see this one because it has like X's in it, but it's not that bad. So if we have time, we'll come back. And you definitely want to see 13. For some reason, the egg shape doesn't intimidate you quite as much. Enough! All right. Number 2, find CD. Well, first of all, what is CD? Well, CD is a compact disc, for those of you that don't know what that is. CD, right there. Okay, cool, we found it. No, that's not what I mean. Check it out. Here's the logic. Screenshot the answer when I'm done. Don't scramble to copy this down. This isn't for a grade. The only time you'd ever look at this is to study again. And if you write stuff on it right now, can you try it on your own? No. Save yourself some time, watch the magic happen, get the idea, and then screenshot at the end. Then you can try it on your own at home. Watch the magic, okay? I wish every class could be like this. If only I made you notes ahead of time where you could watch up here the entire time. I don't know. If only I did that. All right, anyway, the idea, folks, is that if we add up this much to this guy, it'll be the whole thing, except there's a problem, right? See how this guy right here already accounts for the middle? And do you see how this guy right here is also like, but like, I got the middle, bro, right? So we counted the middle twice if we add these up. You see what I'm saying? This guy counts the middle, that guy counts the middle. So we counted the middle 1 too many times. So what we're going to do is we're going to add these up and subtract the middle once. Just once, because we want one of the middles to be there, right? So maybe this guy gets to keep his middle, and this guy we're going to subtract the middle, okay? So this guy right here is x plus 7. He gets to stay, the whole thing, right? This guy, on the other hand, we're going to subtract from him. So we're going to add him to this, because we're adding those two pieces together. But we're going to subtract the middle part, right, from him. So now we have 11x minus 2 minus this amount. So that's going to get us this, right? So now we have this plus this. That's really what's going on here. And that's going to equal the whole thing. What's the whole thing? What do they say the whole thing is?
13x minus 2.
Let me break that down in slow-mo again. We have this part right here in purple. And then we have this part right here, but minus this middle part. So we scribbled that out because he already counted it. And the way we did that is by subtracting 3x. Does that make sense? We subtracted 3x here because that's how long that is. And that gets us this much. This guy plus that guy is the whole thing. So I wrote that. Now we're going to do some arithmetic and algebra. We have 1x plus 11x's. How many x's is that? 12x's. Anybody can outdo that? No? Good. So 12x's minus 3x's. How many x's is that? Anybody can do better than 9x's? Good for you. You're young. Minus 2 plus 7. That's plus 5. Now we're here. Terrible idea in real life, great idea in math. We're going to get our x's together in the same place. I'm going to subtract 9x from both sides. And so I get 5 equals 4x over here minus 3. I'm going to add the 3 over. We're going to get 8. I'm going to divide by 4, and we're going to get 2. I love how you guys are writing this down. They never listen. Now, we need to find CD. We found x. We need to find CD. Well, I know that this much is 11x minus 2, right? Right? So if I subtract that bit, don't I get CD? Do you see how this is too much? So if I take away that, I get this much left over. So whatever this is going to be 11x minus 2 minus this part, right? We don't want that. Because that's too much. We need this gone so we can get this, which will be CD. What's 11x minus 3x? 8x. Minus 2, right? Now we know what x is. We just found out that x was 2, right? So 8 times 2 minus 2. 8 times 2 is 16. Take away 2, 14. Hooray! We found CD and it's 14. Is it everything you dreamed it would be? Ava's like, yeah. Yeah, it was. Number 3, the easiest problem and the hardest problem on the test. If you know what you're doing, it makes sense and it just flows. If you don't know what you're doing, good luck memorizing it. So let's talk about concepts here again. Take a screenshot at the end. Did anybody want a screenshot of the last one, or you already wrote it all down? That's what I thought. YouTube, sometimes. All right. So here's what we're going to do. Start with Pythag. One of the Maddies. What is Pythagorean Theorem? Gotcha. It's got some letters in it. You want to help him out?
Yeah, a squared plus b squared is c squared.
Gotcha. So we're going to start there. That's Pythag. So when it says start with Pythagorean Theorem, write that down. Not now. Take a screenshot. But like on the test, you'll write it down. No, continue as you are. Continue as you are. There you go, right? I can't stop you. You got tattoos. I thought about that for math school. Like, seriously. Like, what are you going to do? What are you going to do? Make me wear sleeves? You can't do that. Freedom of speech. A squared plus b squared equals c squared. That's Pythag. Now we need to know what these points are. Don't forget that. So I'm going to label those points. Let's start with the far left point. It's some coordinate, right? So we might as well call it x1, y1. Now check it out. Look at these two dots. How are they the same? How are they different? One's higher than the other, right? Oh, sorry, Corinne. So one's higher than the other. So they're different vertically, aren't they? One's on the bottom floor, one's on the top floor. Think vertical like an elevator, right? They're on different floors here. So if he's on Y1, the other guy must be on Y2. Remember, Y is the up and down. So if he's on the bottom floor, the other guy must be on the top floor.
What was it, X1?
They have the same X value, though, right? Because they're the same distance to the right. They're the same distance to the right. So X1, Y2 is that point. They're different vertically. They're the same horizontally. Now down here, this point is different horizontally, right? See how I have to travel to the right to get to him? They're different places horizontally. So if that guy's on X1, this guy's on X number 2.
We can't see the top.
Oh, you can't see it at all? I'm sorry. Here. I had tape on here, but then this thing moved, and now it's not working as well. So I'll go back and do this. So this point right here, this dot, they're different vertically, aren't they? So they have different Y values, Y1 and Y2. But they're the same horizontally, because if I move to the right, I hit them at the same time. Remember, horizontal is right and left? So they're the same horizontally. Now this guy, different horizontally, right? I start here and I move to the right. Two different locations. But they're the same vertically, right? They're on the same floor. Yeah. Well, this one's Y1, so that one's Y1. They're both Y1s. Because they're on the same floor, right? Think of it like a hotel. They're both on the ground floor. Same Y values. This guy and this guy, different floors, different Y values. X's are the same, X's are different. So what does this tell us? Well, if we wanted to know how long B was, what we'd do is we'd subtract these guys. Remember, subtraction is distance, right? So what happens when I subtract Y1 and Y1? A number minus itself. 0, right? Goes away. Are these the same number? So they don't go away. So B is going to be X2 minus X1. The Y1s went away. A, on the other hand, what happens when we subtract X1 from X1? 0 goes away, right? So it's not that. It's going to be Y2 minus Y1, right? Because those don't go away. I need that. And I need an explanation of why this is. So first of all, subtraction is what? Starts with a D. Subtraction is not division.
It's this time, the D is that.
That's okay.
Distance.
Distance, yep. I'm asking it all the time, guys. Come on, subtraction is distance. So first of all, it's distance, right? Because that's why there's subtraction there. But what kind of distance? Vertical or horizontal? For this one up here. Horizontal because it's the x's, right? So that's horizontal distance. I need that. Now down here, it's subtraction, so it's distance, but what kind of distance is it going to be? Vertical because it's the y values. I need that. Now that you have this, check it out. It's telling us that B is this stuff. And it's telling us that A is this stuff. So wherever we see A, we can switch it out with this. And wherever we see B, we can switch it out with that. That's what we're going to do next. So Pythagorean theorem says A squared plus B squared equals C squared, right? But instead of A, I'm going to switch it out. What am I going to switch out for A? Y2 minus Y1, right? See where we're getting that? A is that. So instead of writing A, I'm going to write that. In the same way, B normally goes here, right? A squared plus B squared. But instead of B, what am I going to write? X2 minus X1. And now we're almost there. That's almost distance formula, isn't it? There's one thing missing. That root. Yes, Alex, is that what you're going to say?
Oh no, I thought X and Y went backwards.
Ah, so here's the deal. Great observation. Let me finish this and I'll answer that. That was great. So to finish it all off, it's just the whole thing rooted. And that's distance formula. We're done. Now, Alex made an observation. Normally when he has distance formula memorized, he has the x's first and then the y's. It doesn't matter which order they come in. And here's why. For that to be different, I had my y's first because A is the y value, right? Now, what if I scribbled this out and wrote A down here and B up there? See how that changes it? Now B is going to have the Y's, so Y's are going to come second. A and B are interchangeable. It doesn't matter which one you call A, which one you call B. The only one that matters is C. C has to be the biggest side. Okay? Does that make sense, Alex? Good question. On your test tomorrow, it could be A up here, it could be A down there, and that's going to change things, right? They're going to flop. So make sure you're looking at the diagram, not just memorizing this, okay? Know what it means. A in this case is vertical, so it's going to have the Y values. If A was down here, well, then it's horizontal, so it would have the X values. Turn the page again. Move on to number 5. Number 5 asks you to do distance formula and section formula. We're going to skip the distance formula part because we've been doing a lot of distance formula lately. Hopefully you feel good about that. If not, we're going to hit distance formula later when we do that weird star shape at the end, right? So let's just do this. Section formula says you should have an M and an N. I'm going to zoom in so you can see what's going on. A ratio, right? Now they don't give us a ratio. They give us a fraction, so we need to convert that into the ratio. I'm going to give you a hint. M is 5, but N is not 7.
Wouldn't it be 2?
It's 2. How did you come up with 2?
Because you're taking it out of 7 and 5 plus 2 is.
So 5 out of 7 goes here, right? That's the 5. But she's saying that the other bit that's left over must be the 2 out of 7, right? If you cut something into sevenths and you take 5 of them, you have 2 sevenths left over, right? 5 sevenths plus 2 sevenths is 1. So the numbers come from the top, 5 to 2. Let's do another example of that. So if I had 5 ninths, we have 5 to what? 5 to 4, because 4 ninths, right, is what completes that. Do you see that's the ratio? A lot of times I see, this is a huge mistake that was on quiz 2. You'll tell me 5:7. And then you're in real trouble because then the numbers get nasty. Okay? Here is section formula. You write it down here. Section formula says, take the average of the x's and the average of the y's. It's just like midpoint. Midpoint's nice because there's only 2 x's and 2 y's, right? So you divide by 2. Here, we're going to have our m and our n. So we're going to have 5 of one of our x's and 2 of our other x. You see where that 5 and 2 came from? That was our m and n. And we're going to have 5 of one of our y's and 2 of our other y. We'll fill those in later. Now, if I've got 5 x's over here and 2 x's over there, how many x's total are we talking? 7. So I'm going to divide by 7, right? The total number of pieces. I've got 5 pieces there, 2 pieces there, 7 pieces total, right? Now, what goes here and here? x2 goes here, x1 goes there. You might think, wait, why does it matter? It does. Okay? If I'm going from point A to point B and I travel 3/4 of the way, look up here. If I'm on point A and I'm going to point B and I travel 3/4 of the way, that's here, right? But what if I'm on point B and going to point A? 3/4 of the way is over here. Do you see how there's 2 different points we can get depending on where we start? So starting place matters. So x2 has to be first. The end has to come first. That's kind of weird, but that's how it's set up, okay? If you goof those and do x1 first, you'll get the other point. You'll get here instead of here, okay? It's okay if it happens, only minus a half, but it's important. x2 comes first. Same thing with y2 over here. That comes first as well. So where are these values? x1, y1, all that stuff? Well, they're up here. Our x1 and y1 come from A. That's our starting location, right? And our x2 and y2 come from B. That's our ending location. So what's our x2? Because that's the thing I have to write first. What's x2? 1. Next one is x1, right? Because I'm finding the average of the x's. What's our x1? -6. So I wrote those here. Our x's both go here. We're averaging the x's, then we're averaging the y's, right? Don't combine your x's and y's. What's y2? Because that's the one that comes first. -8. And what's y1? Very good. Now we're here. Now we just do arithmetic. So p is going to equal all that divided by 7 and all that divided by 7. 5 times 1 is 5. 2 times -6 is -12. Right? We're adding these here, right? Because we're averaging. But that's a negative, so it's minus. Here is -40. And we're going to add -2. Well, subtract 2. Cool. Now you'll notice that 5 minus 12 is negative 7. And negative 40 minus minus 2 is negative 42. And those come out nicely. Negative 1, negative 6. So that must be the point. That is 5/7 of the way from A going to B. Let's graph that. If I graph my points, A is at negative 6, 1, 2, 3, 4, 5, 6, down 1. That's A. B is at 1, negative 8, 1, 2, 3, 4, 5, 6, 7, 8. And I connect them with a straight line for Mr. Eads. He gets upset when I don't. You'll notice that our point is negative 1, negative 6. Negative 1, negative 6 is right here. That looks about 5/7 of the way going from A to B, right? It's more than half. There she is. Questions? Okay. You also need to find the distance for that. Plug in your numbers to distance formula. What's distance formula? You did it on question 3. The big root, right? X is subtracted and then squared. Y is subtracted and squared. Add them together. That one. As we continue on. Number 6. So here's the deal. Normally when we do midpoint formula, we plug in our endpoints and divide them by 2, right? Normally that's what we do to find midpoint. But here they gave us the midpoint. So we can't plug in both our endpoints. We only have one endpoint. Our other endpoint is going to be x2, y2. It's the things we don't know, right? We know the midpoint. So m is the midpoint. That's 1 comma 5 halves. And that's going to equal our x's divided by 2. Well, we only know one of our x's, right? The x we know is negative 3. And the x we don't know is the other x. I'm just going to call it x because there's only one of them now, right? It's coming from here. So 1x minus the other x, or adding the other x. The x is negative, so it's minus. Then we have our y2, which we don't know, so I'm going to write it as y. And then our y1, negative 2. That's the setup. Now, what does this mean? Well, check it out. These are both coordinates. That means the x part here should be equal to the x part here. And the y part here should be equal to the y part there. So write that down. 1 should equal x minus 3 over 2. Yeah? And this means that 5 halves should equal y minus 2 over 2. Now we do algebra. Get rid of the division. Times by 2, we get 2 equals x minus 3. And we add 3 and we get 5 equals x. Over here, multiply by 2. Ladies and gentlemen, if I take a number and divide it by 2 and then multiply it by 2, don't I get the original number back? Right? Divide by 2 and then double it. Right, we get the same thing. Take a pizza, cut it in half, now double it. We're back to the original pizza. So 5 divided by 2 times 2 is just 5. Add 2, we get 7. So the missing endpoint that we're looking for, E2, is 5, 7. E2, Brutus. Yes.
5 minus 3 is going to equal 1.
Say again?
5 minus 3 won't equal 1.
I'm here. We agree, right? I multiply by 2, I get this. Do we agree? Oh, sorry. I multiply by 2, I get this. Do we agree? Then I add 3 over here. And I get 5. Do we agree?
Yeah, but if you plug it in.
Plug it in. Plug it in where?
If you did, if you were to find the midpoint.
Oh, good. So, yeah, if I went back and checked it, 5 minus 3 here, if I plugged in x, 5 minus 3 is 2. 2 divided by 2 is 1. That's what you're saying. I like how you're checking your work. Skip 7, skip 8. I hope you can name angles. Skip 9, skip 10, skip 11. Let's get to 13 real quick. It's just like the homework. First of all, how many sides do you see there? Someone other than Tucker, count them.
8.
Nothing but love for you.
7 again.
Octagon.
7 again. After words.
Concave or convex?
Concave.
How do you know it's concave?
Things pointed.
Yep, it's pointed inwards. In other words, we have an internal, 2 of them actually, internal reflex angles, right? Snap your elbow type of angle. Let's find the sides that are easy to count. Oh, wait, none of them are. They're all at an angle, aren't they? Mr. Mac. I know. So what we do is Pythag, right? Looks like that guy is 1, 2, 3, 4, 5, 6, 7 on the bottom. Yep. And that guy's 2 here. Let's do it in our heads. What's 7 squared? 49. What's 2 squared? What's 49 plus 4? 53. We root that, right? So root 53 is this side length. Root 5/3. Now be careful. Those look congruent, don't they? They look like they're the same. But are they? If I measure from here, 1, 2, 3, 4, 5, 6 down here and 2 up there. So they're going to be different, right?
Yeah.
What's 6 squared?
36.
2 squared is 4, so 36 plus 4 is? 36 plus 4 is 40, and we root it, we get root 40. This guy over here, that's a 3, and that's a 3. What's 3 squared?
9.
What's 3 squared again?
9.
Add them up, root it.
18 squared.
Root 18. This guy right here looks like 3 vertically. How much is down here? 1. What's 1 squared? 3 squared is? Add them up. Root them. Root 10. That's root 10. Super tiny. All right. Here we have 1, 2, 3, 4, and down 3. Finally, a 3, 4, 5 right triangle. That means this guy's a 5, isn't he? Which is all you'll ever hope to be, is a 5. Keep trying 3s. All right, here we go. That's 3 again. And then this guy looks like 4 as well. So guess what? We have 2 congruent sides here. Those are both 5s. Notice that this guy's a 3 and a 1, which is the same as this one over here. So if that was root 10, this is root 10. So they're congruent. And then this guy over here looks like 4 by 3. Oh, yay. Another 5, right? So that's a 5. So we have 3 5s, 2 root 10s, a root 18, a root 40, and a root 53. Let's write all those down. 3 5s is how much? 15, right? So let's just write 15. We've got 2 root 10s. So I'm going to write 2 root 10. Right? Remember that from earlier? We've got 2 root 10s. I have 1 root 18. I got 1 root 40. And I've got 1 root 53. And that's the answer for the perimeter. It's gross, but it's true. Sometimes the truth is disgusting. But that it. Mr. Eads, do you concur? Indubitably.
I do believe.
You want to see 9, 10, 11 real quick?
Not for them are easy.
It's got X's in it. Don't fear your X's. The key is right here. CAF is this angle, and that's 85. So if that's all 85, 85 minus 35 minus 40 gets you what's left, right? Go get that X. If you want to watch this one, I did it on a different video online. Check it out. If not, my goal is, before I go to DeKalb today, I got to leave after school today, but before I go to DeKalb, to have me recording, doing without any kids slowing me down, so you can pause, because I'm going to go fast, right? And rewind. I would encourage you to do that. I go through the entire packet with explanation.
Can I come in here during homeroom?
Yeah, you can. Everybody can come in during homeroom. Before I